Hi, my name is David Jakubowski, also known as Neo for Codemons. I'm self-taught software engineer and game developer, and I specialize in C++. In this course, I will teach you the basics of the C++, and I will do this in the Visual Code environment, as well as I will use the CP reference for guidance. The reason why I'm going to use the C++ reference is because this reference contains all the necessary steps for you to write code in C++. CP reference is very complex website where you can find many important topics related to this programming language. So if you will search C++ on the Google, you will see that C++ is described as high-level general-purpose programming language, and this guy, Barney Strostrup, if I spelled correctly, probably not, is the author of the language. He is considered to be the main author, let's say. And C++ originated from the C. C was very low-level programming language compared to the C++. C++ implemented the classes and objects. It's called objective programming. And it also implemented generic programming and many things you can find about the features directly from this website. So this is the cpreference.com, and here you will find all information about all syntax of this language. It is quite complex. If you just go to the just for the first strike comments, as you can see, it's written like a Wikipedia, like a very small and strict Wikipedia. In it you will find many technical details about the concepts, and we won't dive in to all of them. For instance, you can check the pointers. You will see the direct syntax used in this language and examples. And related topics. Okay, so what do you need to start your journey with the C++? I highly recommend using Visual Code. Visual Code is free to use editor. It might be considered to be IDE. IDE stands for Integrated Development Environment. So it's like a toolbox where you can store all the projects and tools to compile your programs, so to translate from the source code into the main target executable. And you can also write your own code. So for instance, I can create a file named main.cpp, and in it I can create example. So I can right now compile this program. This is let's say this is our first program, Hello World. You don't have to understand the logic behind this source code. I will just, for this, the first time, I will just use the G++ main.cpp, and this will compile the source code into the program, and it outputs the hello world string. Now let's delete the main CPP and let's delete the target we have just created. So before we begin, we will have to understand many topics related to C++ workflow, how the development is made in the C++. First, we have to check what is the compilation process. You as a programmer you are responsible for the writing the logic of the code, and then you have another responsibility to take the source code and compile it using special program called compiler into the executable, into the result. Compiler during the compilation process, it's also called translation process, is checking the source code if it has any syntax errors. If it has, it returns an error. But if the syntax is all correct, then the source code is translated into the result. It is for most of the times, it is the executable. Sometimes it's library. So library is like a package of the ready to use functions, classes, objects in packed package. Executable is like an application. You can create executable from the source code, and you can run it directly in your environments: Windows, Linux, macOS, and so on. So the most recommended way by me, and probably by many people, is to use the GNU GCC compiler set. If you are on Linux, on Windows it's MinGW. MinGW is a Windows port for the GCC, and GCC is the most used compiler by programmers. So you can write you can type MinGW, and you can download probably from the SourceForge. You can download the MinGW to your desktop and install the MinGW. MinGW will provide you with the compiler. Visual Code is available here. So it's code visualstudio.com. You can download. For me, it's Linux because I'm on Linux. You will probably work on the Windows, on Windows, and my system is Linux, it's Ubuntu. So I have the packages with for the Linux. You can also download for Windows and for macOS. It is all available. You just follow the steps to install it. And once you have the compiler and the Visual Code, you can start writing your own programs in C++. These two things, editor and compiler, these two are essentials. It's essential requirement for the programming work. Editor for the editing the source code, compiler for compilation process. So let's create first program. I advise you to use the main CPP name, and we will create first program. First, we will include the header file named IOStream. IOStream provides you the input and output for the console. So this header allows you to use special object named cout in the main function to output some data, strings, numbers, floats, and so on. Let's just write test. And we have to end the cout with the end line. I know that this is already looking complicated, and we will just compile it. For now, as you can see, it outputted test. So what this program means. First, let's look at this sorry for the setup mess. Let's look at this main function. It is the function called main. It returns number, integer, that is returning an error for the run. So if you return 0 as a return value, it basically means that you are returning no errors. If you, for instance, return 1, it will return error. But it is not visible by default. On the Visual Code you see on my terminal, there is some signal that the main function returned error, but if you run on the normal terminal, it won't show the error. So main function is a starting point for your application. So you can visualize the process of the run of the application in steps. So first it hits the main function and it runs the first line. Starting point, main function, it is required by default. And then it goes the cout. It outputs the test. Next, it goes the return 0. Return 0 returns the error code 0, which corresponds to no errors. This part is executed step by step. This and this, this and this part is the declaration of the function. Inside the brackets is the definition of the function. This part is basically the header of the function. Main function is required by default. It is also, as you can see, there is an error. We have removed the main function and it returns compilation error. Actually, it's linking error. And if you will see, if you look at the CP reference and go to the main function, you'll find this required and it is implemented by the compiler as a general starting point. Main function is not required if you will attempt to compile the library instead. Library does not require main function. Executables applications do. Okay, so let's create our starting point and think for a moment what we can do here. We can create variables. Variables are small packages of data and they have type. So for instance, we can create integer. Integer corresponds to the even number. For instance, 5. We can define another number, integer, for instance, 4. And we can return the result. Of addition. Let's compile and let's run. As you can see, output is 9. There are also other types of variables. Variables store values. This is the general idea of the variables. They have the implementation in the memory of the computer. They have their own static fixed size. So if you declare integer, it has already assigned size in bytes. And every type has its own size. It can have 1 byte, 2 bytes, 4 bytes, and so on. We can create float. Float is it's not a real number, but it's very similar to real number. It can have parts after the even parts. We can output the number 1 plus number 2, and let's return end line character. As you can see, 2.5 plus 2.1 equals 4.6, which is true. Cout is the object defined in the standard IOStream header, and it can be used. It is the part of the basic IOStream of the C++ standard library, and cout can be used anywhere given that you have the include with the IOStream. Minus character allows you to subtract the values. It works with the floats, it works with the integers, so even numbers. There's also multiply. Sorry, I have a save. 6. You can also divide, it's the slash. But in this case scenario, division of the integer numbers does not give parts. So 6 divided by 3 will, of course, is going to output, sorry, I have to save, 2. But if you, for instance, divide 7 and 3, you will also see, sorry, I have to save, 2, not 2.333, because we know that 7 divided by 3 it's 2.33333, and this 3 infinite part. To change this, we can change the type to floating point. As you can see, now we have the more correct answer, let's say. Why the 7 divided by 3 equals 2? For very basic reason. Division does not return parts. If you want to return part, we can use the modulo operator, which returns the part in even numbers. So modulo is the modulo operator. Modulo takes the first number. For this case scenario, it's 7, and it divides it by 3. So 3, and so 6, and it gives you the return value after the division. So it's 1. Because there's 7, so we have the 7. It divided by 3, and it has only 1 as the result. The fourth, it's called fundamental type. The fourth fundamental type is bool. Bool can have the logical value false or true. False also means, in many conversions, 0, and true returns 1. So false is basically a logical sentence, gives you the negative result, and true corresponds to positive result, the truth of the sentence or false of the sentence. Logical values can be returned, as you can see, 0 and 1. We can also change the formatting by passing the cout, so this input-output object. We can also pass bool alpha. I think it's like that, if I remember correctly. Yeah. So you can pass the bool alpha flag to the cout, and 0 and 1 is returned as string, false, and true. Bools can also be used by special logical operators. For instance, false, alternative, true. These two bars, I don't know what these characters are named. Let's say these two bars represent alternative. So false alternative, true returns true. Let's check the result. 1. So it's true. False alternative, false should return false, false. True alternative, true. We know that it should return true. Second operator is AND. AND requires two operators to be true in order for the result to be also true. So true and false should return false. False and true, of course, also returns false. False and false returns false. And true and true returns true. Okay. And the third operator is negation. So it inverts the logical value. So false negated is true, true negated is false. So true and true returns true. It's very simple, very basic. These types, integer, floats, logical values, booleans, and also characters, char. They can also store in single quotes one specific character. One char can store only one character. It's the syntax rule of the C++. So these four, integers, floats, booleans, and chars, or characters, these four are named, and this is the comment, it's get ignored by the compiler. These four are called fundamental types. Fundamental types are the most essential and impossible to divide to the smaller parts types. So you cannot divide the integer to two divisible types. It's impossible. There are also other types, such as classes, and they, for instance, string, string, and they can be divided to many small elements. But fundamental types, by default, cannot be divided to at least two parts. Integers, shorts, longs, and long can be considered the most frequently used fundamental types, and these four store integers only. So these ones are the integers. Floats and doubles store floating points. Floating point numbers. Bool is the only type for the Boolean type, and char is character. Keep in mind that character char is also integer. The reason behind this is because one character is stored inside the ASCII table. I'll show you in a moment. We can check the ASCII chart, and as you can see, we have the characters A, B, C, D, uppercase, A, B, C, D, lowercase. We have the special characters over here. We have numbers, we have characters, and these ones are special characters. I think that's what they called. So each character has its own integer value, integer ID, let's say. So for instance, slash is in fact number 47. Let's verify it. Let's use 47 as an indicator of a character. So let's create character with the ID 47 that in ASCII chart means slash. Let's compile and let's output. As you can see, the output is slash. We can also pick, for instance, I don't know, 57. Let's compile. And the character is 9. So in C++, characters, for the efficiency purposes, are stored inside very small integers. Characters they are very small. I think they are the smallest integers. Short is a little bit bigger, integer is bigger, and long is also bigger integers. Longs can store very high numbers. Longs and integers can store like 3 billions, I think, something. Shorts can store like 75,000 something. The exact sizes of the integers can be found in fundamental types in this table. We have the character over here, size in bits 8, signed and unsigned, values between 0 and 255. Integers are also characters. Character is also integer, and size we can have, for instance, 16, 32, 64, and these are the ranges each type can have. So we can create shorts, we can create unsigned short, we can create signed ints, we can create unsigned ints. And unsigned means that you can store only positive numbers or 0. 0 is not a positive number. So unsigned in each type means that you can store only from 0 to some range defined by the type. Signed numbers can store also negative numbers. So as you can see, for instance, let's take the character. So signed, unsigned version from 0 to 255 can store from 0 to 255, and if you change this to signed, then the scope shifts and you can store between minus 128 to 100 positive 127. So the scope shifts. Signed and unsigned can be used in character declaration or definition and integer declaration or definition. Floating points. As you can see, there are no signed or unsigned keywords associated with it. So these are the basics of the fundamental types. Other types are, for instance, let's do this. Let's increase the scope of the screen. So there are other types. On CPP reference, you can find this in the section named types. And as you can see, we have very complex classification of each type. We have fundamental types. There is void also. We will discuss void in a moment. There is a null pointer which returns the no address value. And we have our floats. We have Boolean, we have integers, and we have characters. Booleans, characters, floats, and integers. These are described here. And it is the technical description of these types. We haven't discussed void, we haven't discussed null pointer. We will do this in next several minutes. There are also compound types. These are the fundamental types. They cannot be divided to other parts. And compound types are more complex. We have the references. References can store the label, or let's say pointer label to variable. So we have variable, we have it in the memory, and we want the address of this pointer, and we want to pass the address of the variable and not the value, the copy of the variable. So reference gives you access to this variable by only passing the address. So you don't pass through the copy of the variable, you pass the pointer address to the data. References and pointers are strictly for that. References are a bit safer. Pointers can be less safe. There are some issues you may encounter with pointers. Pointer to member types, we will discuss this in later parts of the video because they are hard to use for beginners. Array types can store the arrays of elements. So we can have array of characters. We can have the array of integers. We can have array full of strings. And they can store any type. So array can store fundamental types as elements, sub-elements. We can store complex types, so compound types, let's say. We can store as sub-elements the compound types. Function types are we won't discuss function types for this moment. Function types are the general information about the return value, arguments of the functions. I know this may sound a bit hard for now. They store the, let's say, declaration, the header of the function. So, for instance, main, but main is very special function. Main is required when we can also create like void function int. We can pass first argument x, second argument y, and we can like output the x and y, and we can call the function inside the main function like 5, 4. Let's compile this. And as you can see, we have the return 9. So function, we have called the function, we have passed 5, 4, those were passed the cout, and they were calculated, plus 5 plus 4 equals 9 as the result to the cout. Functions, we will discuss functions in several minutes. Enumeration types store the special labels that store very small, for most cases, integers IDs. So enumerations are declared by keyword enum. We specify the name of the type, so the type is given a special label. We can specify like, I don't know, false equals 0, true, and true automatically gets assigned next value, previous value incremented by 1, so it's basically 1. These are the enumeration types, and enumeration types can be used also in many places inside the source code. They are treated as labels, but they are basically converted to integers. Enumerations, they are a little bit different from integers, but they store IDs. So you can see red, yellow, green. Green equals 20, blue is 21, red is probably 0, yellow is 1, because the first element by default gets the value 0. And we have class types. Class types are the most complex ones, and they store data. They can store several data. For instance, variables. They can store functions, they are called member functions, and these member functions can execute some code. So class is a type with the data and the behavior, data in the form of variables and behavior in the forms of functions. And these functions can call each other, they can call to other places in the source code. We will discuss classes in next parts of this course. Okay, so those are the types. As you can see, the syntax of the C++ is complex. This is the CP reference. As you can see, we have this is the pointer. Pointer is declared by star. Static cas is the cast to specific type. Arrays are declared by the square bracket. Inside the bracket, we specify for most of the time the amount of elements. So we declare this is the definition of the 3-element array with 3 integers in it. This one allocates the array. Allocation is a different way of creating variables. This is the I won't explain this one to you. It's a pointer to some kind of array. I'm not even sure what it is. I'm not sure what it is. It's probably just allocation. This is the declaration function declaration, and those one are the classes. The function inside the std is class. So these are the most advanced types you can find. Classes. We will discuss classes in next parts. Okay, so this is it for the basics of the variables. Now, in C++, we have to understand that types which specify the way the data is organized, the types in C++ are very, very, very strictly specified. For instance, you cannot do something like this. You cannot have, for instance, class A. We have something in A, and we can create integer B, and we cannot assign the A. This is the value object A. We cannot assign to fundamental type the compound type, such as class. We cannot do this. If we will attempt to do this, we are going to get the compilation error. Cannot convert class compound type to fundamental type integer. It's impossible. There are possibilities to convert types to other types, but by default you must understand. By default you must, because this is the fundamental of the C++. C++ contains types, and those are strictly, hardly wired inside the source code, and they have to be specified, sometimes perfectly. If you miss the type, you are basically asking for the compilation error. This is also written inside the Wikipedia about the C++. It has the typing discipline: static, nominative, partially infuriated. So strong typing, it's called. Strong and weak typing. Weak types, programming languages with weakly typed types, they are more easily converted and used in specific contexts of the source code. Okay, I have to check the 49 minutes. Okay. Okay, so I'm going to make a pause and let's continue in the next part.